literally beyond that next star. They're within us, woven into the threads that bind us. All of us.
So, if that's not clear, all this imagery is actually from Google Maps or Earth products. So it's all generated from this, from the content we already are hosting in our products, which I think is pretty amazing. So, with this intro, let me tell you what I plan to talk about today. So, I'll start by sort of explaining how we got where we are now. And it's kind of an interesting story and journey. It's not kind of a straight path to, you know, panoramic, immersive imagery of the world. We had various, you know, directions along the way. And then I'll give you a glimpse as to what we are, you know, sort of what we're focusing on now as a company, especially the imagery team. And then talk about how what we are providing really is kind of a canvas for all your creativity to be unleashed. And I'll explain a few things that we're working on to make this work. So, by the way, I'm going to use this little guy here, Pegman, I would call him, as our guide through this journey. We have a very creative marketing team who's come up with a whole bunch of outfits for this dude, so it's kind of fun to sprinkle them in my presentation. He's the guy you use when you're in Google Maps to sort of bring up the imagery. You grab him and drag him to the map where you want to see street view imagery and beyond. So here's our user number one. This guy's Larry Page. He's our founder and CEO. About 12, 13, maybe even 14 years ago, he had this idea that, you know, there was useful information, useful data, useful tidbits at imagery taken at street level, and he, you know, being very, you know, having a very broad vision for Google, wanted to, you know, make this imagery available, useful, discoverable for users. And so he wanted to bootstrap research on how to make that imagery, that type of content, you know, available and useful. So he actually took a camcorder and drove around the Bay Area with his camcorder, capturing hours of video. And then he, in order to bootstrap research into making this useful, he donated that footage to Mark Lavoie, the CS professor at Stanford. And he essentially also started to kind of a small research grant with that group. And bootstrap what was going to be some sort of research into what became Street View. And I should point out that this is not really, by the way, a new idea. The idea of having imagery tied to, I mean, geographically located imagery and having some sort of navigation based on it dates back just like until the late 70s. A product called Aspen Movie Maps from Lippmann, who did this, you know, based on a complex setup that involved Laserdisc in the UI. It's pretty advanced for the time. So the idea was not new, but the notion was that you know, we could do it better at larger scale and do it right. So when Larry started this research project with Mark Lavoie's team at Stanford, Mark Lavoie, being, you know, a computer vision scientist, was not really interested in just collecting imagery and publishing it. He was interested in doing something new research-wise. So he came up with a notion of actually taking videos that would be sideways from a moving vehicle, a video of the facades, and then by taking strips of pixels vertically in these videos and gluing them together, he envisioned you could create these what's called push-broom perspective panoramas. That would be like these infinite panoramas of facades. And the advantage of this, it's very efficient to represent and serve, because you don't need to, as you move around the panorama left or right, you don't need to refresh a whole view, right? The perspective is such that, you know, it's the same as you move left or right. So if you were to serve this, you would just break into small tiles and serve each tile, and they would be very efficient. Notice that it comes with some interesting artifacts, however. All the cars, you know, became European cars, even though they were large, you know, pickup trucks to start with. This is the street of Palo Alto. So anyway, so that was the notion. So my point here is that we didn't get to 360 panoramas right from the start. At the beginning, we just wanted imagery to be somehow made useful, and the first idea was these panoramas, which we actually never ended up publishing, even though what's funny is that Microsoft actually used those in their products, but it was very successful. So that idea works very well if you're on a flat street. So if you're driving, imagine you're capturing a video, you're driving at even speed on a flat street, it's fine, you can create these kind of panoramas, kind of experiences, but if you start having some bumps, and if you stop, or if your speed is not even, you get things like this. Obviously very ugly and useless. So thank you. That drove a bunch of requirements on the Street View research vehicle. So this vehicle here is what we used when we started bringing the project to Google. So I should tell you about my own journey here. So I joined Google about 10 years ago, 10 and a half to be exact. And that was sort of 2 years after Larry had started this experiment with Stanford. And when I joined, this project, this collaboration with Stanford became my quote-unquote 20% project at Google, meaning my side project. And over time, I sort of brought this back into Google as I understood the place better and why it made sense for us to embark into this kind of project. So it started in the first sort of 6 months of my involvement as a research collaboration, and then it came to Google. And in the collaboration phase, we're using that vehicle, which was this hodgepodge of electronics, cameras, and setup. So we had these SICK lasers, to sort of measure distance to facade, which was required to create these panoramas. We had the fast, camera here, Basler, high frame rate camera, GPS and various computers there to drive all the systems, including, new batteries, because all this drew a lot of power. So we used a Google security guy on loan from the security team to help us, drive this every day and capture imagery and try to debug it. So we're both trying to debug and come up with a reliable car platform for capturing this imagery, as well as coming up with a bunch of, software pipelines to process the data and make it useful. Very quickly, we ran into some issues which we solved creatively. The first one was that the power was extremely unreliable. And so after messing around with these batteries for too long, we said, well, at this point, all we need is like test data, no need to mess around with this. So we put a generator on the car. Essentially like having a lawnmower on your roof, and every day we would just, start the thing, and so it worked fine. So we had no power issue after that. We also had, a lot of strange looks from pedestrians as we were driving at the time 10 miles an hour down the streets of Palo Alto and Mountain View and San Francisco. So we sort of decided to be a bit less conspicuous and add this beautiful, custom enclosure here with, one hole for the camera and two for the lasers. But that worked pretty well. And so we spent the first summer of this project with about 10 interns and half a dozen sort of Google 20% contributors, and we were able to create this kind of experiences, this kind of results. This is 18th Ave, so you probably can't see much on this because it's downsampled to heck, but it's like a 50,000 wide image of 50,000 pixel wide or more of all of 18th Ave in San Francisco. We proved that we could actually create those things, and in fact that our localization was good enough to even capture the relief. So here it's not straight because that street actually has some hills. And we also created the first mock of what may look somewhat familiar now, but that was at the time the notion was that you would publish these push broom perspective panoramas in the context of the map, and then be able to navigate the space both by dragging in the imagery or by dragging in the map. And the blue dot here shows where you are, the green shows street that have coverage, so it's a bit kind of a precursor of the current UI. So we had enough, that we could show, give a tech talk about this kind of project, and have reviews with our execs, and sort of at that time it was decided that we were showing enough potential that it should be, scaled. So we got the go-ahead to be able to hire people on this project and make it real. So as we thought about this, we had now a small kernel of a team, 4 or 5 people, passionate about this. So how do we do this? Well, we figured that, first of all, that the cost of operation for this was going to be dominant. So we decided to build a platform that would have a lot of equipment on it, such that we would capture everything we might possibly need, down the road to create these experiences. So instead of putting just one laser, or two lasers, we put actually 9, 4 on each side and 1 in the front, just to be able to capture enough, enough density of points to get a good 3D experience. Instead of having just one camera on each side, we decided that these panoramas that we were trying to build were so hard to build, so complicated, and we weren't sure about the experience quite yet. We hedged our bets, a very good move in retrospect, and we added this tower, which was the first rosette of cameras. It was 8 of them. It was just cylindrical. There was nothing looking up. But this was like a way for us to capture sort of immersive panoramic imagery at the same time, just in case. Then we had this sort of mini data center in the back to power this equipment again, and this custom fairing to hide all this. It was a beast. So these cars were like $5,000 used, but probably all the equipment was easily 10 times that or more in there. And in fact, the issue we had with them that they were just too complicated. We never were able to build more than a few of these cars. Something was always breaking, so live and learn. This was just too much. Nonetheless, with those, we were able to launch, so about a year and a half after we got the go-ahead to start the project, we had built enough of these systems, not just the cars, but the software pipelines, the front ends, integration with maps, that we were able to launch just about 8 years ago, Street View. And at the time we launched in 5 cities only. We had like 5 city cores. We didn't really know when you launch a new product like this, a new space, didn't really know what the reaction was going to be, so it was a test, really. But very quickly, we saw that people, there was interest. When you launch a service like this at Google, the beauty is that you can observe traffic to your servers, and and also you can look at the reaction in the press. And we saw that the traffic was going through the roof, the press was going on and on about this. So we're onto something. And I think what was really key was that people were just interested in looking at their own house, and their friend's house. And then we had enough density of coverage in each of these 5 areas that you could really expect to if you looked for a place in your neighborhood, you would find it. And people were quite interested. So success now, even though we had imagery that was very, very poor. So for experts like yourself, it must be pretty funny, but we found that the imagery quality didn't really matter that much. People actually, our users, found it funny with all these stitching artifacts. You can see here, our rig didn't trigger all 8 cameras at the same time reliably. And oftentimes, as we're driving by, you may have up to a quarter of a second delay between the first camera triggering and the next one. And so you would create weird stitching errors like this where the same people are there twice. This was on Golden Gate Bridge. Other issues we found, we found newer shrink cars. This is like a very new model of Porsche. Again, it didn't seem to matter. People were engaged. People, found the content compelling. I think the combination of having the content and the map and being able to navigate the content sort of virtually was pretty engaging. So that was very, very good for us. But quickly we realized that we could not scale these vans. So we had, I think, 4 or 5 of these big vans. They were breaking all the time, and at this point we knew we were sitting on something valuable for our users, but we had to be able to scale that beyond these 5 cities. So what to do? We cared a lot about image quality, so we didn't really want to go off the shelf right away. So we ended up building various prototypes. This is one of them. This never saw the light of day. I think it never went beyond the garage here. It was too scary looking. Seemed overly top heavy. This is I think, something called R3 for Release 3. So after messing around with this for a little bit, we decided that perhaps the thing to do at the time was to scale and not worry too much about quality. So we went completely off the shelf. We bought these cameras from a company called Point Grey in Canada, and they have these Ladybug cameras. This was their Ladybug 3. And we built this Street View Lite, as we call it, with totally off-the-shelf components. So off-the-shelf GPS, no lasers, because we hadn't found a way to use the laser data yet. We removed the side-facing, high frame rate cameras, which we didn't use. We put just an off-the-shelf Dell computer in the back, and off we went. And we built a few dozen of these, and we were able to scale in the US rapidly with this. And then, after we've learned, after we're able to sort of, better, gain experience with hardware, we're able to build the first, real Google, designed camera for this kind of use case. And this is the R5, release 5, was released 1 to 4, not having been released outside of the Google lab. So this has like 8 cameras in a rosette, plus 1 fisheye looking up, so 9. We put back the lasers because at the now we knew how to use them to create a better navigation experience, how to use the laser data and the depth data. And anyways, it's more of a custom built car for our purpose. And we've been deploying them, around the world. So here you see a few of our, places where we assembled the cars in various parts of the world. And we took them for a spin. And so over the course of 2008-9, we really started expanding first in Europe and then the rest of the world. And this is the next gen. So it's actually the first ever car built with our current generation camera, which is the R7. This R7 did a few things for us. First of all, the last generation only had a fisheye looking up. Therefore, as you were looking at our imagery after stitching, you would find that when you started looking up, if you have tall buildings in the scene, for example, or big trees or something you want to look up, you would see a seam where the imagery was nice and sharp, and then it became blurry and fuzzy as you were looking up. Not good. Also, the configuration was such that there was much too big of a hole that you couldn't see around the car. And in areas like narrow streets, you would often clip the bottom of buildings. So we decided we need something that was more even resolution, and we created this soccer ball configuration with 15 lenses. We also managed to make it a bit more compact to reduce parallax, which was good. And so we expanded well beyond the first original cities. And right now, so after many years of doing this, we have 65 countries, maybe even 66 as of today. I forgot. We really can't keep track. Some countries, of course, are tiny, like Andorra, Luxembourg, and some are very large, like the US. So but anyway, we have data in 65 countries, and in fact 7 continents. We even have Antarctica imagery. This being said, there's still some very, very large holes on this map, and I'll get back to this in just in a bit. But you can tell we don't have much coverage in Africa. Obviously, we have nothing in China, nothing in India. So a large part of the world are still without good street view imagery. But we're on it. So, was there a question?
Yeah, is there like a military base in the middle of Germany?
Let's see, what's in Germany? No, I think it's just the resolution of that blue outline. There is imagery in Germany. I'm not sure what that hole is. We have 20 cities. So whenever we launch, we also have it's always fun. So I'm always amused by looking at what people find in imagery. This one is one of my favorite examples. In Norway, we launched that about 5 years ago. We found these 2 guys in dive suits by the side of the road having a beer, and then if you navigate to the next image, you see these 2 guys chasing the car. So what the heck? And there are examples like this of fun stuff all over the imagery. And in fact, one reason why the imagery was so popular early on was that people came up with their screenshots and linked to imagery of various kinds, and that generated lots of interest in traffic. So this turned out to be planted. We found out later that the driver had like friends, and he had asked them to stop by the side of the road as he was driving by. So let me shift gear here and talk a little bit about a few things that have been keeping us busy from day one on this project and still keep us busy today. As you may imagine, there's a whole bunch of technical challenges in bringing something like this to 65 countries and hundreds of millions of users. So one of them that is still keeping us busy is the challenge of pose. Pose refers to localization plus orientation. So it's like XYZ plus 3 orientations. It is exactly what describes the exact position of a panorama in the world. And for Street View to be useful, it's more useful if the panoramas are well located. So there's like a key requirement for us to have great geolocation, great pose for these panoramas. And one thing that was not obvious to us early on was that you can't reuse raw GPS. GPS is just useless. This is an example of raw GPS here in Pittsburgh or wherever I was using that sample data. it jumps all over, and it's more and more jumpy the more you are in areas of tall buildings where you don't see enough satellites to get a fix. So what you really need to do to get good data is to rely on other sensors. And in particular, there's two types of sensors that are critical. One called IMU, for inertial measurement unit, essentially what you have now in your phone as well, that measures acceleration and various orientation. And then you also probably want to be able to tap into the car CAN bus or somehow find a way to measure velocity of your car. So that if you go into a big, long tunnel, you can sort of still use dead reckoning and type, things like this to keep track of where you are. So bottom line is you want to use a whole bunch of other sensors, and in fact, even another technique, which I'll talk about in a minute, to sort of get the best estimate of the pose based on all these measurements, right? So that's what you optimize over. And you can see that this, this lets us go from like the left to the right, where the data here is very well aligned with the map. So we've been working on this problem for quite a bit of, quite some time, like 8 to 10 years, because there's always ways to improve it. The code that some of the early code we wrote for this is open source on Google Code, so it's probably now migrated to GitHub. And we're still working on this because it's super important for the experience. What early on we found that our stuff was working fairly well. These are examples: raw data, ugly, optimized data, nice, but it didn't work all the time. Oops! Sometimes early on we had these issues where the optimizer would fail dramatically, and we ended up in the lake. Oops! Bad. So that. And if you don't discover this, so again, imagine this is processing data, from hundreds of cars or dozens of cars, automatically, and it's not obvious to find these kind of errors automatically. So if you don't find the error, you end up publishing imagery in the wrong place. We've had situations as well where a sensor would fail, and somehow our tests, weren't thorough enough, and so there was a situation where a car that was supposed to be collecting imagery in Germany, somehow the GPS showed a straight line all the way going through Europe, going through Netherlands, and so we ended up publishing imagery of Germany in the Netherlands, and a user actually reported, and it was almost impossible to find. It's very, very amusing. So, as I said, we're still working on this problem, so this is like a very complex space, and one thing we've learned a lot about in the past 8 years is about GPS in particular, how GPS is quite complicated. And your GPS in your phone does a lot, but there's a lot more you can do, and you